So today, um, we are going to be talking about, um, we're going to do the next step. Put it this way, we're going to get into the next step in statistical analysis. And as you all know, this is just a basic overview of statistics. So we have three chapters. Um, the basis of statistics is, probability theory. Because we have random data and patterns are not exactly perfect, and so and various factors influence the pattern of data and the size of measured variables. And then the next step, which we did last week, we talked about descriptive statistics, which is just a summary of data that enables you to have a general idea of what data is. And the next step is now measures of dispersion. Okay, the first step essentially is descriptive statistics. And then, like we said, the basis, foundation of statistics is probability, which essentially means that data is not perfect. There are various factors that influence the characteristics of variables. And so the next step after descriptive statistics is to look at measures of dispersion. In descriptive statistics, we essentially have summaries like means, averages, okay? And then the next one is dispersion, in the sense that the imperfect data is dispersed, the values of imperfect data is dispersed. Let us take a very simple thing in nature. Like you go to a poultry where the chickens lay eggs, and you will find out that the weight of the eggs is not exactly the same. Okay, the average may be 2 ounces. That some may weigh 2.1 ounces, others weigh 1.9 ounces, some weigh 1.8, and some weigh 2.3. And so we have a dispersion of the characteristics of the variable, that is the average weight of the eggs. Then there's a characteristic in that the eggs in the poultry, their weights are dispersed around the mean. They could have a particular kind of characteristic. The weights of the eggs will not be far from the mean. The average is 2, and then some weigh 2.1, others weigh 1.9. So if you take 3 eggs, one weighs 2 ounces, one weighs 1.9, the other weighs 2.1. The average is 2, and you can see they're dispersed around that 2, and they may not be far. Each egg will not weigh much more than 2 or much less than 2. Okay, so this measure of dispersion, we call the variance in statistics. Generally, at this introductory level, we don't deal so much with the variance, but the variance is the basis of what we will talk about. We will talk about a standard deviation. The standard deviation is simply the square root of the variance. And that is usually sufficient for a whole lot of what people do in nature, in decision-making using mathematical methods. We use the standard deviation. So today I'm going to I'm going to illustrate the calculation of the standard deviation, and also look at some examples of standard deviation. So be patient. Okay. Let's look at a very simple example. Like I said, I'm going to share screen. Here is a simple example, okay? We look here at a variable. I'm going to call that variable x. Can you see my screen?
Yep.
Okay, all right. So let us say we have a variable x, okay? And the variable has the values 228, 241, and so forth and so on. And so we're going to take 10 of them. Okay. I'll stop share screen. I'll share a new screen. Okay. So we have a variable that has values. These values will be a car rental where passengers, where customers rent cars. We simply asking ourselves, what is average number of miles that these passengers use the car? Okay, what is average number of miles? So that is a basic miles. So how many miles? Okay, the first passenger drove 228 miles, another 241, 190, 326, 291, 210, 333, and so forth and so on. And there are 10 passengers here. And so we ask ourselves, what is the average number of miles? Okay? That is the first step in the calculation of standard deviation. Okay? And then after that, then you follow a formula for calculating standard deviation. But the first step is to ask yourself, what's the average? Because the number of miles driven will be dispersed around the average. Okay, and so for this, I'm going to copy this. Now, in statistics, we use the term the average. Okay, so let us calculate the formula for the average. Okay, formula for average is the sum of values divided by number of observations. Okay, And so here we have 10 observations, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 observations. And so the sum of the values would be summation x divided by n. So in that case, what do we have? I'm going to use the Excel to find the sum. I'm going to use Excel to find the sum. And so I'm going to go back here. Okay. So the sum will be you can use the Excel facility. And so the sum will be 2,634. And the average, this is the sum. Okay. The average, or what we call the mean. The mean is simply another way of saying average. V equals F16 divided by 11. Okay, was F16 over 11. And so the average mileage will be 239. That is the very first step in calculating the standard deviation. So let's now go and look at standard deviation. I just want to be sure that our calculation is correct. Okay, get the same thing. We had 11 observations, and so we had that formula. Now, to the next thing that really is important to us is to calculate standard deviation, because this is what we have come here to do today, to look at a measure of dispersion. There are different measures of dispersion now, okay? You have the variance, which is the very foundation of dispersion. And then, of course, the standard deviation is the square root of the variance. But you also have things like mean deviation, you have kurtosis, which actually looks at the shape of the dispersion. So, but for our purposes, we'll simply focus on the standard deviation. All right, so let's look at the formula for standard deviation. I'm going to put it up. And I'm going to also illustrate it for our purposes. All right. So that's the formula for the average. And for our purposes, we find it to be Stream seems to be frozen again today. Oh, just excuse me. We found our average to be 239, I believe. 0.45, something like that. Now, to get a dispersion, what we're actually trying to look at is the way that the values of the variable miles are distributed around the mean. Okay, so you have, this is the mean here. At the center, the mean is at the center, and the values are distributed around the mean. Some of them bigger than the mean, some of them smaller than the mean. And so you have values here, values there, and some are far away, some are close by. These are all values of the variable, but the mean is in the center of the values of the variable. So now let's look at the formula. Formula for standard deviation. Okay. The formula for standard deviation is quite simple. X, the value of each X, the sum of the differences between the value and X and the mean. I use X bar, which is the sample mean. Okay. Divided by n minus 1. Sum of the squared values. And we take the square root of that. So this is very simple. Some people will write for the population standard deviation, we use the sum of the squared deviations, X minus now this is the population standard deviation. But for our purposes, let's assume that we are doing a sample and you can use n minus 1. If you think you have a population, use n, you use n, the large n. Now, in statistical analysis, we have a sample, we have the population. The population is if you have the values for every member of the population. And the sample is simply a selection from within the population. Suppose, for example, you were asking yourselves, what is average travel time for students who go to school on campus? What is average travel time? Now, the population will be all the students that went to a campus on that specific day. And so if you have that information, then you're looking at the population. But suppose you decide that you didn't want to find a way to identify everybody that came to school, which will be time consuming. And you just wanted to take a random sample. And so you walk into a classroom and you have 30 students there. Those 30 students represent the population of students. And so you take you take an average and a standard deviation based on that sampling of students, which does not include everybody, but just those that you happen to see in a particular location. And so we assume that they represent the entire population. And so you call that a sample. And the sample that you collect, the information from that sample, the average is called X bar. The population average is called mu, okay? That's what we call it, mu. All right, this is mu. And this is called X bar. All right, so let's now facilitate this using Excel. And after we do the Excel, we're going to essentially use, after we do the calculation, we're going to use Excel to make it very simple for all of us. So I'm going to take this off. All right. So this is miles. And the mean, we say is, the average is that. And so we have X minus X bar. I have X minus X bar squared.
I can't see your screen.
I don't know if you meant to share your screen again.
Yes, I need to do that. Thank you very much for calling my attention to it.
No problem.
Okay. I'm going to start all over. Okay, so we have X minus X bar, which is the deviation of each value from the mean. And then we have X minus X bar to the power 2, which is the squared deviation from the mean. Okay. So now we subtract this from the mean. The mean is in F17, which is equal to F5 minus $F $17, which is the mean. So we fix the value okay. F5 minus $F $17, which fixes the location. And so we subtract from so you can see some are positive, some are negative. And if you were to calculate the sum, you get a 0. That's what you get, okay? This is to the e to the power 13, you want to so that's a 0. And then you square it to equal to 5 to the power 2. And so you square all the values that you get. All right. So you sum the values according to our formula. Okay. So this is the sum of the values. And I'm going to write that down. I'm going to move out of that screen. That is 28,754. 28,754. And I'm just going to so now, as we said, the standard deviation is the square root of this number 28,754, divided by 11. So let me come out of this for a minute. Okay. And so this will be 28,754, 28. By 11. I can say over 10 since I'm assuming a sample. And we get the square root of that. And so can somebody give me that number? 8,754 over 10. Okay. So what do you get? Did somebody get an answer? Hello?
I'm not sure if I put the formula in correctly, 53.6.
That's correct.
Okay.
53.62. So that is the answer, 53.62. That is the standard deviation. It is not difficult to calculate. And so I'm going to take this off, and maybe we can look at one of your homework assignments. Okay, I'm going to look at one of your homework assignments, and I'm going to now use the Excel function to solve the problem. And that way we kill two birds with one stone, which is, I'm going to look at this, says the bus, okay. Download the file, sort the data by manufacturer, and calculate the average cost and standard deviation of maintenance. Okay, so let's okay. Are you seeing the data? Or are you still seeing Blackboard?
Blackboard.
Okay, so I'm going to share the data itself. Okay, so are you seeing the file, the Excel file now?
Yeah, Excel.
Okay. So now you can see here, we have the manufacturer, you have Bluebird, and you have Thompson. Okay. And so we're going to and then have Kaiser and Thompson. Okay. So let us see if we can. Okay. Okay, I have sorted the data according to fuel type. So how would you do this assignment? You have to do this assignment by looking at, say, the number of miles. Let us calculate, compare the mileage according to fuel type. So I'm going to copy this. Copy diesel. This is diesel. So this is diesel. Then I'm going to copy gasoline. Excuse me. Gas. All right. So We get the average. Like we said earlier, in order to calculate standard deviation, you see that you need deviations from the average, deviations from the mean. So the first step is to calculate the mean. So we take the average. Equals average. And you can just paint it, or you can identify the location you want. So the average number of miles for diesel vehicles is 829. Okay, this is average. And this is diesel. And this is gas. So here, I will go again, equals average. So you have your averages. It's very simple. And like I said, make a chart. See, it's very simple to make a chart. You insert. And you make a chart. And I usually like to move my charts. Average. So your chart is now in a separate sheet. I'm gonna just give it a very simple averages compared. And you give it a label if you want. So let's go back to the data. Now the standard deviation. And the deviation will be equals standard deviation, STD, S, and you choose your locations. You can memorize the locations and simply sign them. The standard deviation here is 41. This is I4 to I56. And the other one is J4 to J30. You can drag over and J4 to J30. And the standard deviation here is 44. So we have gone through that homework assignment to make it easy for yourself. If you want to do a chart, Now, usually we don't do charts of standard deviations at this very simple level of statistical analysis. And so some students go and do a chart of the standard deviation. So we don't do a standard deviation for that. We don't do a chart for standard deviation. If you're doing advanced statistics, you may have to do charts for variances. We really don't do charts for standard deviations. And the standard deviation is the square root of the variance, or the variance is the square of the standard deviation. At that level, we have different reasons why we do charts for variances, because we are making comparisons between more than two different variables, or we are looking at other measures or other influences of the variance for purposes of decision making. For example, we use variances in decision making to measure risk in assets, measure risks of investments, and so we have a reason for comparing charts and doing things like that. But here at this level, we'll just focus on the calculation of standard deviations, and we can use the standard deviations for making decisions also. Like, for example, for risk, for conflict resolutions, we use standard deviations. So that's about it for what we have to do. And so if you have other questions, please raise them now.
Yes, Dr. Agbe.
Yes, go ahead.
So for the purpose of this homework assignment, then, for that specific question, you are only looking for a chart for the average.
Yes.
Questions. Okay, because I was like not sure about that when I read that. Okay. Okay,
a chart is just for the averages, and so you can see both for the housing assignment and for the vehicle assignment, as for charts, and charts are just for the for the averages.
Okay.
All right.
Another question for you on this.
Okay.
So when I was working on this, I did end up using the standard deviation sample function.
Yes.
But I was a little bit unsure, right? Because it looks like this is all of the data for this busing company.
No, it's not.
It's not. Okay.
It's not. But I mean, even if you did it for the population, or you did it for the sample, I wouldn't differentiate, because this is not where I'm testing your ability to recognize the sample or population. You should remember that the buses here, there are several buses here, and those buses have been driven for probably a whole year. So that could not be, for several years. So that could not be the population statistic. So even if it is the first year, I mean, professionally speaking, that is just, you are still looking at a sample, because you are not able to identify all possible ways that these buses could have been driven. And to just clarify that, in statistical analysis, we differentiate between population and sample. And the reason we use sample and sample methods is that you cannot truly identify a population. Let us take Manhattan, for example. What is the population of Manhattan today?
I don't know. 10 million?
Don't know. It may be 10 million. Well, that's the population of New York City itself. The point I'm trying to get at is, can never truly measure the population of a place, because people come in and go out. People move in and move out every day. So what is the true population? Is it the population you saw yesterday, or is it the population you see today? Is it the population that was there 2 weeks ago? And so whatever you see actually is a sample.
Okay, so this seems then like it would be much less frequent that we would use the population formula.
Absolutely, absolutely. The whole idea in talking about in doing statistical analysis, and the reason we talk about population is that we know there is a true population out there, but we just are not able to lay hands on it, period. And so the whole idea of a sample is that the sample represents that population. For example, if you want to calculate, say, the average income of college professors, you take a sample of college professors. You don't go and take a sample of, say, students. You don't go and take a sample of construction workers, because they do not represent professors. If you want to get measure the characteristics of construction workers, you don't go and take professors, because they do not represent the population that you're looking at. Nevertheless, whatever you see in a group represents essentially a sampling of
I got you.
Of all possible characteristics that could be in nature. And so we can never truly measure population.
Okay, so it seems like the population formula is used for like very more finite, clear groups.
Yes. If you think that you really certain that this is a finite group and it's immutable, and this is it, then but the reference to population is I think in my professional opinion is theoretical, and it serves a purpose. It serves a purpose because there could be a population. It's just that we generally are not able to lay hands on it. Or it could be time consuming to lay hands on the population.
Okay, so then I guess it's safe to say then though, if you wanted us to know, like if it were on the final, you would say assume it's the whole population. Okay.
Oh yeah, I can see, I assume it's the whole population.
Okay.
All right.
Thank you.
Okay. Any other questions? All right. Hearing none. Thank you all for stopping by.
Oh, actually, yes, I have another question. I'm sorry.
Go ahead.
What was I going to ask you? Oh, for the second question regarding we're comparing equity bonds.
Mm-hmm.
I'm sorry, let me find it.
Equity bonds, no, it's not equity bonds. Equity assets and bond assets.
Yes, thank you. I just want to make sure I'm understanding the question. I understand the, how to calculate what you're asking for in it, the average of the assets, the performance. I'm just not sure. Do you want us to put in like a paragraph comparing how the funds are performing, or do you just want to see the math?
Let me see. Right. What is okay? I just want to see, that you did the calculation. I'm going to look at, either you do it by hand or preferably using Excel, but I'm going to look at your Excel file and be sure that you use the right formulas. You didn't just get an answer somewhere. It says, calculate means and standard deviations to compare the equity funds with the bond funds. Be sure to compare the asset sizes, performance, and expense ratios. So you're looking at three variables there that you should compare in terms of the average between the two kinds of funds, the bond funds and the equity funds. That's it. And then the next question, looking at their standard deviations, I wouldn't want you to compare their standard deviations, but you can just mention them. And the reason, remember I had told you that we use standard deviations as a way to measure risk. So if you divide the standard deviation by the mean, you get something that is called coefficient of variation. And that is used to measure comparative risk between equity funds and bond funds. But I'm not asking you to do that.
Okay.
You can intuitively say, the equity funds have a higher level of deviation than the bond funds, but we didn't get into that in this class. And maybe this is going to be a reason for me to bring it up. Maybe next semester I'll modify the assignment and also discuss with students the use of the coefficient of variation. Coefficient of variation is not difficult to calculate or even to interpret. So it wouldn't be beyond the level of this class. But you have brought up a good point.
Okay, gotcha.
All right. All right. Any other questions? All right. Hearing none, please enjoy your break.
Thank you.
After the final exam. All right.
Thank you.
All right. Good night.
Good night.